Okay, tomorrow's lab is going to be finding the molar mass of an unknown volatile liquid. So what we're going to do is you're going to start with a barrel pipette, which looks like this. That's what I'm drawing here. And you're going to take it, for the very first thing you want to do is we want to know how much does this plastic weigh, how much does the barrel pipette weigh. So you're going to mass the pipette by itself. Then you're going to take in 2 to 3 milliliters of an unknown volatile liquid. And that's actually taking in more liquid than we'll need for that liquid to evaporate and fill the whole barrel pipette. The tip of this is really narrow so that it's going to be, the gas will be pushed out as you evaporate this gas, and we won't be taking in much air from the room. So it's going to be like, it's a very narrow tip, it's going to be hard to push the gas out. So we can assume if you take in 2 to 3 milliliters of an unknown liquid and then heat it up until it turns to a gas, that this pipette will push all the air from the room out, and it'll just be filled with the unknown liquid in the gaseous state. So the first thing you do, you mash your empty pipette, then you take in 2 to 3 milliliters of your unknown liquid. Then you're going to put it in a hot plate, and we'll leave it there for 5 minutes. And after 5 minutes, you're going to check and see if there's any liquid left inside. If there is, heat it for another minute or so. If there's no liquid, then we can assume that all the liquid has evaporated and has filled the barrel pipette. So now I have a pipette that's full of this gas, and what I can find out about that gas, I can find out the temperature of the gas by taking the temperature of the hot water bath, and I can assume they're the same because they've been in contact for 5 minutes. So I have the temperature. The barrel pipette is open, so if I find the pressure of the room, I'll know the pressure of the gas in here. And then later we can find the volume of the pipette. So then we'll have the temperature, the pressure, and the volume of the pipette. We can find out how many moles of our unknown gas are filling the pipette. The third thing you're going to do is take your pipette and put it in an ice bath. And as you put it in the ice bath, all the gas that's still in the pipette is going to cool and it'll condense into a liquid at the bottom. You'll just have a drop, not nearly as much as you had to begin with. So just a little bit of liquid. So we'll leave it in here just long enough to get cold, and then check and make sure that you do have a little bit of liquid at the bottom. At that point, you're going to dry off your pipette, and you're going to get the mass. So initially we had the mass of the empty pipette. In the end we had the mass of the pipette plus however much liquid it takes to evaporate and fill the whole pipette. Okay? So our whole goal is to get the molar mass, and we know for molar mass is going to be how many grams per mole. And we can see the grams we're going to get because we'll have the mass of the empty pipette, and then we'll have the mass of the pipette plus however many grams of unknown liquid it takes to fill this when it's in the gaseous state. So this we're just going to mass and get the difference between the two. The moles, we'll use PV equals nRT because we know the pressure. This is open, it's room pressure. We'll know the volume because we'll show you how we'll get that. And the temperature from taking the temperature of the hot water bath. Okay, and then that'll tell us the moles. So these are the things we're gonna measure as we go. We'll need the mass of the empty pipette, the temperature of the hot water bath, the mass of the pipette with the unknown liquid, and we're going to need the mass of the pipette with water. So after you've done your experiment, go ahead and fill your pipette with water, totally full, and then we'll get the mass of that. And what we're going to do from that is we're going to do some calculations from all that data. So the first thing, we're going to find the mass of your unknown gas. So from that, we're going to just take the mass here, the mass of your pipette that had the condensed liquid, and subtract the mass of the pipette before you began. Okay, and that'll give you the mass of that liquid right there. Second, we want to find the volume of your pipette. So we'll use the density of water at room temperature as 0.997 grams per milliliter. So for that, that'll be the mass of your pipette when we filled it with water at the very end, minus the mass of the empty pipette. That'll give you the mass of water that fits in here. So we'll have some number of grams of water that fits in your pipette, and we'll convert that from grams to milliliters to get the volume of the pipette. The third thing, we're going to calculate the moles of your unknown gas, and we'll do that because we'll know that when this was heated in the hot water bath, we'll know the temperature of the gas, we'll know the pressure of the room, because we'll look it up on Google. And we're going to know the volume of this because we figured out the volume in number 2. And we can use PV equals nRT to get our moles. And we'll calculate the molar mass by taking the grams and dividing by the moles that were present. So let's try giving some data. So I have the mass of the empty pipette is going to be 2.02 grams. So this is the part where you're following along at home. This is your pre-lab. Your pre-lab is to do this calculation with me and bring this calculation in to turn into me tomorrow. Or if you're in Ms. Noshiba's class, do this calculation and turn it into her. So the first thing we're going to go ahead and figure out is we want to find the mass of your unknown gas. So that's going to be the mass of the pipette with the little bit of condensed liquid at the very end minus the mass of your empty pipette, right? So 2.031, oops. So 2.031 grams minus it was 2.02 grams when it was empty. Okay, so that gives us 0.011 grams. Okay, so that's going to be the mass of that little bit of liquid right there, because we subtracted the mass of the plastic basically. So next we want to find the volume of your pipette. So what we look at is the mass of the pipette with water is 9.02 grams, conveniently. We're going to take away the mass of the empty pipette, and that gives us the mass of the water, right? So we had 9.02 grams was the pipette plus water. I'm going to put P plus W. We're subtracting the mass of the pipette, minus 2.02, so we get 7 grams, right? So there's 7 grams of water that fit into the pipette. I can use the density of water to find the volume of the pipette. So I have 7 grams, and for every 0.997 grams, there's 1 milliliter. Okay, so I type in 7 divided by 0.997, and I'm going to get there 7.02 grams, or sorry, 7.02 milliliters. Okay, so that is the volume. That's the volume of the pipette. So the next one we're going to do is we're going to calculate the mass of the moles of our unknown gas. And I'm probably going to need a little more room than that, so let's do this. So I'm looking for moles. I know PV equals nRT, right? And I'm looking for moles, so I want to get N by itself, so I'm going to divide both sides by RT. Okay, so I can see N is equal to PV over RT. Alright, so let's say in lab that day, we'll write whatever the pressure is. Let's say it's 1 atmosphere. Convenience. And the volume is what we just figured out. So the volume was 7.02 milliliters. I know for PV equals nRT I need to use liters. So if I have 7.02 milliliters, there's 1,000 milliliters for every 1 liter. Okay, I'm dividing by 1,000. I'm going to go 1, 2, 3. So 0.00702. There's that many liters. 0.00702 liters. And the gas constant is going to be the R, so 0.0821. That's liters, atmospheres per mole Kelvin. And the temperature, let's see, the temperature of that hot water bath was 95 degrees Celsius. So I have to turn that to Kelvin. So I say 95 Celsius plus 273, and I get 368. Okay, so 368 Kelvin. Okay, so go ahead and multiply these, divide by these guys, and you end up with 0.00232 moles. So there are that many moles of your unknown gas. Okay, so that'll be right here, number of moles, 0.000232. Okay, and for the last one, calculate the molar mass of your unknown gas. For that, I'm going to use some more space. For molar mass, I know the units for molar mass are always going to be grams per mole. So I'm going to take the fact that I know I had, how many grams? I had 0.011 grams that gas, and it was in 0.000232 or 2.32 times 10 to the negative fourth. That's moles. So go ahead and type that in, and when you calculate it, you should get to 2 sig figs 47 grams per mole. So that would be the molar mass of your unknown gas. And we'll give you a list of gases to choose from. Make sure you're dressed for lab because we're going to use glass and we'll be heating glass and cooling glass. So see you tomorrow.